Today topic is alcohols, phenols and ethers. Some important reagents. Important reagents for this chapter. The first one is Lucas reagent. Lucas reagent. This Lucas reagent is used to distinguish test. Distinguish test distinguish test of alcohols. Distinguish test of alcohols. Okay, so what is the Lucas reagent? Zinc chloride plus HCl. Zinc chloride plus HCl. See, primary alcohols, first of all, secondary alcohols are giving immediate reaction. Immediate cloudy white cloudy solution is given. White cloudy solution, that's immediate. Secondary alcohols are giving after 5 minutes later. 5 minutes later is giving same reaction. Then the primary alcohols are not giving this reaction. If you heat it after 1 hour, it will give. Okay, this is the main distinguish test. Distinguish test means by physical observation you can identify which is the primary alcohol, which is the secondary alcohol, which is the tertiary alcohols. Next, the second important reagent is zinc dust. Zinc dust. This zinc dust is used to prepare benzene from phenol. See, in the phenol and benzene, what is the difference? Only one extra oxygen is there, right? So if you use the zinc dust, it will absorb this oxygen, then it is forming benzene. Then the third one is, next, this third, copper 300 degrees Celsius. This copper 300 degrees Celsius is dehydrogenating agent from alcohol. Okay, so these secondary alcohols, by removing these two hydrogens, forming ketone. Suppose from this ketone, if you reduce by using lithium aluminum hydride, the short name we can say LAH, lithium aluminum hydride, again you will get it alcohol. If you know this type of reagents, you can do easily conversions. Sometimes the question will ask, how can you prepare from isopropyl alcohol to ketone or ketone to isopropyl alcohol? So this type of questions you can do by using this type of reagents. That's why the reagents are very, very important. Next, suppose primary alcohol is there. Primary alcohol, the alcohol group which is attached to carbon, the carbon is connected to only one more carbon. Okay, that is primary alcohol, right? These primary alcohols, by reacting with copper 300 degrees Celsius, giving aldehyde, right? Then again, if you use this lithium aluminum hydride to aldehyde, these are giving primary alcohols. Next, tertiary alcohols. Tertiary alcohol means like this. Here, this is the tertiary alcohol. Okay, after removing this, here there is no hydrogen here, right? That's why it will remove water. Instead of hydrogen, it will remove water from adjacent carbon. So you will get it alkene. You will get it alkene. From this alkene to, if you want alcohol, you can do just addition of water by using diluted H2SO4 plus HgSO4. HgSO4. Then you will get same product. Okay, these are the reagents. Next important one reaction. Important reaction is formation of ether. Formation of ether. First, Williamson synthesis is there. Williamson synthesis. Okay, here the general equation is Rx plus RONA is, I can take here R dash. So R dash bond OR. This is the ether. Now the conditions are, this Rx should be primary, and one more important thing is this reaction is carrying SN2 mechanism. Okay, this R whatever it may be, no problem, but the condition is here it should be primary alkyl halide. Okay, if Rx is secondary or tertiary is there, if Rx is secondary or tertiary is there, then leads to alkene. It leads to alkene, right? So I will take one example here. Ethyl chloride plus ONA, right? O minus Na plus, then it gives C2H5 oxygen like this. Okay, it is SN2 mechanism. Next, suppose C2H5 ONA, O minus Na plus is there. Is a very, very important reaction this is. See, I am taking here tertiary alkyl halide, then it is giving alkene. Okay, this, why after leaving this chlorine it is a tertiary carbocation. Before that it is a strong base. So it is taking one hydrogen from any one of this CH3. Okay, suppose from this CH3 one hydrogen is left, then it is giving alkene. Okay, so this is the major product now. Understood? Next, one more important reaction, this ether cleavage. Ether cleavage. This ether cleavage C2H5 bond OCH3 is there. By using HI. This HI, H plus I minus. See, this is also SN2 mechanism, ether cleavage. In the ether cleavage, SN2 mechanism means no intermediate. This is the very simple fundamental rule. No intermediate. right? Suppose here we have suppose here A and B, two possibilities are there. Here two possibilities are there, A and B. Suppose if A cleavage is there, then it is forming CH3 CH2 plus. If B cleavage is there, it is forming CH3 plus. So which is the more stable? It is the more stable. This is unstable. Unstable. Unstable means this is SN2. It is following SN1 favor. ये दोनों में. Among these two, this is more SN2, right? So this cleavage takes place faster. Okay? Among these two options, the B cleavage takes place. So the C2H5OH plus methyl iodide. Methyl iodide. Then are you getting? Next, suppose phenol one side and methyl is there. Now the cleavage, how it will be? Very simple here, resonance is there, benzene and oxygen के बीच में. That's why this bond cannot break up easily. So obviously the bond will break in between oxygen and methyl. So you will get phenol plus methyl iodide. Okay. So ether formation, ether cleavage, and distinguished test. So these are very important reactions and reagents. Now we will discuss question and answers, right? Now question and answers we will discuss. Question number 1. Question number 1. Which of the following represent increasing order of boiling point? See here, boiling point is directly proportional to intermolecular bonds. Intermolecular forces are bonds. Okay, so in this functional group, if hydrogen bond is there, obviously that is more. Then it is also directly proportional to surface area. As well, it is directly proportional to molecular mass. If molecular mass is same is there, then next we have to see surface area. Okay, the molecular mass is, see, hydrogen bond is the first preference, then molecular mass is second preference, then surface area third preference. This is the preference, right? Now if hydrogen bond is there more, see in the first and third. In the first is alcohol, right? Second is ether, then third is again alcohol. So hydrogen bond and hydrogen bond is there. Ether तो सबसे least, so least होगा. 1 and 3 में surface area 1 is more, so 1 is more than third. So your answer will be 2, 3, 1. That means D. Right? Are you getting? This is the D answer. Next, question number 2. This alkene is converting into alcohol. This is the Markovnikov product. This is anti-Markovnikov product. If you take diluted H2SO4 and H and water, you will get OH is at tertiary position. That is Markovnikov group. But we have to get anti-Markovnikov product. For that, see, out of 4 options, the first one is completely reducing agent. The C option also reducing agent. then B and D में answer होगा. B is giving Markovnikov product, that is tertiary alcohol. So obviously D is the your answer. D is the your answer. In that D, what we are using, B2H6 we are using, B2H6. In this B2H6 is the dimer of BH3, dimer of BH3. Okay. Now in the BH3, boron is plus 3 oxidation state. So BH2 plus H minus, BH2 plus H minus. Okay. So now according to Markovnikov rule, the negative particle is attacking, this negative particle is attacking wherever less number of hydrogens are there. That means here. Okay. So this pi bond is shifted to here. This BH2 is attacking here. So this mechanism is like this. So here hydrogen, there BH2. The next step, BH2, while hydrolysis or in the presence of H2O, hydrogen peroxide, this OH is replaced by this boron, BH2. So you are getting like this. So finally answer is D, right. Next, alcohol reaction with sodium. Sodium is there. This sodium is highly reactive, it can displace this hydrogen. So it is giving RO minus Na plus then hydrogen half. Okay. So all active hydrogens, active hydrogen means more electronegative atom attached hydrogens, can displace by these strong metals or active metals. Next, SOCl2, SOCl2 में covalent compound. This ROH plus SOCl2 is giving RCl. There is no ionic compound here. Ionic compound is there. That means A is the answer. Okay. Next, PCl5. PCl5 may be same. PCl5 also RCl only we are getting. In case of H2SO4, by concentrate we will get alkene. Okay. So answer A. Next. See first one, A option, CH3CH2OH, by oxidation it is getting CH3 double bond OH aldehyde. This one is a ketone. So here dehydrogenation is not takes place, here dehydration is there. It is forming alkene and water. Okay. So C is the option. C is the option. Why? Because it is releasing water molecule instead of H2. Okay. Question number 4th, right? Question number 4th का answer C. Now question number 5. This question number 5. The benzene, two OH groups are an adjacent is there, that is called catechol. Catechol. And meta position is there, resorcinol. Resorcinol. Then opposite is there, 1,4 position is there, that is quinol. Quinol, right? अभी this resorcinol used by zinc dust. Zinc dust का काम क्या होता है? Just remove the oxygen. So here it is forming just benzene. So your answer will be B. Next, question number 6th. Anisole. Anisole means you have to know the structure at least, then only you can answer it. Very simple. Anisole means benzene and OCH3. Methoxybenzene we can say. It is the ether functional group is there, and reaction with HI, the starting discussed this important reaction, cleavage of ether. Obviously the bond will be cleavage here, so forming phenol plus methyl iodide. Phenol, two options are there, methanol, iodomethane, right? C is the option, right? Sixth C. Then seventh question. Acidic strength we are showing by Ka. Ka is directly proportional to minus inductive and minus mesomeric groups, right? And right. सब में तो फिनॉल है, right? अभी at the same time you can understand 1 by plus inductive and plus mesomeric group. If plus inductive and plus mesomeric group is there means that is less acidic nature. So here B सबसे least होगा, उससे better A से better C से better D. Why C and D? How can you distinguish? How can you separate? See, C में only minus inductive group. Here in the D minus mesomeric. Okay, group is only NO2, but the NO2 at meta position acting as only minus inductive, but same NO2 group at para position it is acting as mesomeric group, right? So what is the answer? Which of the following is least acidic? Means B is the answer, right? Next, question number 8. The compound incapable of hydrogen bonding with toward the compound incapable of hydrogen bonding with water is, see, hydrogen bonding. For hydrogen bonding conditions you have to know that one side is hydrogen, the other side is fluorine, yeah, oxygen or nitrogen. The second condition is the hydrogen should be connected with any one of these elements. Then only hydrogen bond is possible. Now you see in the water ether तो formation है, ठीक है, CH3 oxygen, CH3 is there, it is connected with this oxygen, means water and ether also hydrogen bond is there. Only B में there is no more electronegative atom, right? That's why there is no hydrogen bond, incapable. Remaining all can form. Ether is there. So you can take C2H5, C2H5 also. Here one more hydrogen is there. In between this hydrogen, this O2 is inserting and forming like this peroxy. Peroxy is forming. Peroxides are forming. Peroxides. Okay. So that's why we had to store in brown color, and in the absence of oxygen we have to store it. Absence of air. Okay. Ethers absorb moisture, ethers evaporates readily, ether oxides to explosive peroxides. So C is the options here. Correct option is C. It is forming peroxide. The peroxides are explosive. Next, question number 10. H5. If you use H plus, what will happen? C2H5 oxygen, C2H5. Here the lone pair is there. This lone pair is giving to this hydrogen. So it is forming like this, right? So this is oxonium ion. Oxonium ion. This place we can write it here also, right? This is the oxonium ion. Oxonium ion. So where is the option? Oxonium salt we can say, right? SO4 is there, no? SO sulfuric acid, SO4 2 minus होगा, ठीक है, taken twice. So salts. So A is the correct answer, right? The next question we can see in the next video.